This is our project on regression analysis by Brooke, Macy, Kennedy, Emma, and Gabby. Hi, this is Gabby Scardino. I'll be giving some background information of what my group members will be talking about. Dependent variables are actual events you wish to predict, whereas an independent variable is a factor that is going to influence the outcome of the dependent variable. Correlation analysis is identifying independent variables that are correlated with the dependent variables. It is also used to make sure that the independent variable is not correlated with each other. Once the independent variable has been identified, the regression analysis can be ran. R-squared and p-values are major components needed for the regression analysis. R-squared explains how much of the independent variable explains the dependent variable. Lastly, if the p-value is less than 0.05, the variable should not be used. I hope you all enjoy our presentation.
Hey, this is Emma. When determining future grades of students who take the class Introduction to Financial Accounting, or otherwise known as Accounting 200, using previous data sets that include each student's individual grades and assignments helps to find what each future student can expect to earn. While the dataset shows everyone's grade overall for each individual assignment in consideration of their final grade, it is important to consider the student's work ethic, work attendance, knowledge, and test-taking abilities for the course when considering the outcome of future students' final grades. In order to best use the dataset, we adapted it using regression and correlation analysis to analyze variables that would have the most impact in considering future students' final grades in the Accounting 200 course. With this project, we found that students who passed the course that wanted to earn an A needed to score 90 on Exam 2 and Exam 3.
Hello, my name is Macy Miley, and I'm going to be describing the steps we took using correlation analysis in our project. Correlation analysis determines whether a relationship exists between variables and then determines the magnitude and action of that relationship. Here's the correlation analysis we ran in Excel. We used this to identify the correlations between the independent and dependent variables. After identifying these variables, we highlighted the variables that were highly correlated with the independent variable, which was total points earned. And then we eliminated the dependent variables that were highly correlated with each other. For our data set, we decided to use students that made a D or better in the class. All exams, pre-lectures, exercises, and bonuses were considered in our analysis. We used 0.70 as our cutoff number and determined that scores of a 90 on Exam 2 and Exam 3 had a high correlation with our independent variable total points earned, and this resulted in an overall course grade of an A in the class. Conversely, those students who did not get a 90 on Exam 2 and Exam 3 will not receive an A in this course.
Hi, I'm Brooke Parker, and I will be talking about the regression output. The R-squared value for the regression without F's came out to be 69.83%. The R-squared value for the regression with F's turned out to be 89.69%. This means that for the regression without the F grades had a smaller correlation than the regression with the F grades. Including the F grades into the regression made the R-squared value larger, which also makes the correlation of the two independent variables, which were Exam 2 and Exam 3, larger. The difference between the two R-squared values is 20%, which is 2 entire letter grades different. The p-value for the regression without and with the F's came both to be 0.00. The p-values needed to be lower than 0.05 to be able to be used. Therefore, we are able to use both of the regression analyses since they met that criteria. One interesting thing we found about the intercepts from each regression is the difference between the two numbers. The intercept for the regression without F's is 197, while the intercept for the regression with F's is 58. The difference between these two intercepts is 139. The intercepts more than doubled in numbers when the F grades were taken out of the regression.
Hello, this is Kennedy Kingston, and I will be discussing our predictions and findings for our dataset. After running both regression analysis, including one one including our F values and one not including them, we found that it is imperative for students to make at least an A on both exams 2 and 3 in order to make an A average overall. As seen on the next slide, we formed our equation to find the exact grade numbers required to make that A average using exam 2 as variable 1 and exam 3 as variable 2. If students were able to meet the 90% mark on both tests and score 100% on every other graded assignment, the students could score a 95 overall in the class. This calculation is based off of a maximum of 500 possible points in the class. This slide is a screenshot of our regression analysis without the F values. This is where you can find our calculations for the grade requirements listed below the regression analysis table. And finally, this is a screenshot of our regression analysis with the F values, where you can also find the grade requirements listed below.
Thank you for listening to our presentation about our correlation and regression analysis with and without the F grades for the Accounting 200 grades dataset.